Question 1. What is a scheduler and what can it help us to achieve in a web application? A scheduler is a mechanism that allows tasks to be executed at specific intervals or at a predefined time. In a web application, schedulers help automate repetitive tasks such as sending email notifications, generating reports, performing database cleanups, and updating cached data. By scheduling tasks to run asynchronously, schedulers improve application efficiency and reduce the need for manual intervention. Question 2. What is Executor Service and why we need it? Executor Service is a Java framework that provides a higher-level API for managing thread execution. It helps in efficiently handling a pool of worker threads, preventing the need to manually create and manage individual threads. Executor Service improves application performance by optimizing resource usage, managing concurrent tasks efficiently, and providing built-in mechanisms for scheduling, shutting down, and monitoring task execution. Question 3. Describe when you would use async and executor service to improve the performance of your web application. The async annotation in Spring allows methods to execute asynchronously, freeing up the main thread and improving response times in web applications. It is useful for non-blocking operations such as sending emails, logging, and background tasks. Executor Service, on the other hand, provides better control over thread management, allowing developers to fine-tune thread pools for handling high-load concurrent requests efficiently. Using these techniques improves application scalability and responsiveness. Question 4. Explain the difference between Future and CompletableFuture. Future is a Java interface representing the result of an asynchronous computation, but it has limitations such as blocking behavior when retrieving results and lack of chaining. CompletableFuture, introduced in Java 8, extends Future by providing methods for chaining tasks, handling exceptions, and combining multiple asynchronous operations. CompletableFuture enables non-blocking execution and improves the readability of asynchronous code. Question 5. Can you list several Java built-in functional interfaces and their usage? Java provides several built-in functional interfaces under the Java util function package. Predicate is used for testing conditions and returns a Boolean value. Function transforms an input into an output. Consumer performs an operation on an object without returning a result. Supplier provides values without taking input. Buy function takes two inputs and produces an output. These interfaces enhance functional programming, making code more expressive and reusable. Question 6. What is the difference between asynchronous programming and multithreading? Asynchronous programming allows tasks to execute independently without blocking the main thread, making it ideal for I/O-bound operations such as database queries and network requests. Multithreading, on the other hand, involves running multiple threads in parallel to utilize CPU resources efficiently. While multithreading is suited for CPU-intensive computations, asynchronous programming is preferred for managing non-blocking tasks without unnecessary thread overhead. Question 7. When creating a thread pool, how do we decide the size of our pool? Please explain your approach at calculating the pool size. The optimal thread pool size depends on the type of tasks and system resources. For CPU-bound tasks, the pool size is typically set to the number of available CPU cores to prevent excessive context switching. For I/O-bound tasks, where threads spend time waiting for external resources, the pool size should be larger and calculated using the formula. Number of threads equals number of CPU cores. 1 plus wait time, compute time. This ensures efficient resource utilization while handling concurrent tasks. Question 8. What is Kafka? How is Kafka different from RabbitMQ? Kafka is a distributed event streaming platform designed for high-throughput message processing. It is widely used for real-time data processing, event-driven architectures, and log aggregation. Unlike RabbitMQ, which is a traditional message broker optimized for reliable message delivery, Kafka is designed for distributed, scalable, and fault-tolerant data streaming. Kafka uses a partitioned log model, while RabbitMQ follows a message queue model with acknowledgements and routing mechanisms. Question 9. What is the usage of consumer groups in Kafka? Consumer groups in Kafka allow multiple consumers to process messages from the same topic in parallel. Each consumer in the group reads from a subset of partitions, ensuring that messages are processed efficiently and load is balanced. Consumer groups enable horizontal scalability and fault tolerance, as new consumers can join or leave the group dynamically without affecting message processing. Question 10. What do you mean by a partition in Kafka? A partition in Kafka is a subset of a topic that allows messages to be distributed across multiple brokers. Each partition is an ordered sequence of messages, and messages within a partition are processed in the order they arrive. Partitions enable Kafka to scale horizontally by distributing workload among multiple consumers and providing high availability through replication. Question 11. What is the purpose of the retention period in the Kafka cluster? The retention period in Kafka defines how long messages are stored in a topic before being deleted. This allows consumers to read and reprocess historical data even after it has been consumed. The retention period is configurable and helps in scenarios such as event sourcing, debugging, and replaying messages to recover from failures. Question 12. What are some of the advantages and disadvantages of Kafka? Kafka's advantages include high throughput, horizontal scalability, fault tolerance, and real-time processing capabilities. It is ideal for event-driven architectures and distributed systems. However, Kafka has some disadvantages, such as increased operational complexity, difficulty in handling small messages efficiently, and the need for careful partitioning and replication strategies to ensure optimal performance. Question 13. What are the components of Kafka? Kafka consists of several key components. Producers publish messages to Kafka topics, brokers manage and store message data across partitions, topics act as logical channels for organizing messages, partitions distribute messages across multiple brokers for scalability, consumers read messages from topics, and Zookeeper coordinates the cluster by managing broker metadata and leader election. These components work together to provide a distributed, fault-tolerant event streaming platform.